All right, so whether it was for fun or by accident, we all have experienced falling. And let's talk a little bit about the physics of falling. So when you're falling just through the air, or an object is falling through the air with no forces except the force of gravity acting on it, we call it free fall. And you hear that term a lot. So let's talk a little bit about what happens during free fall. And what's going on is there is an acceleration due to gravity. So there's a force due to gravity, provides an acceleration due to gravity, and that's the only thing acting on the object. As the object gets closer and closer to the Earth, it accelerates and the velocity increases at a constant rate. And we call that acceleration due to gravity. We just use the symbol g, really nice and easy, little g. And its value is negative 9.8 meters per second squared. And we use negative because it's falling downward, so we're indicating direction. So if you need direction, you want to use the negative. What's going on? If you look at the picture that's here, you can see the guy lets go of this mass, and if a strobe is flashing at equal times, you can see that each time that little mass travels farther and farther and farther, even though the amount of time between each picture is exactly the same. That shows that the velocity of the object is increasing as it moves downward, so it is accelerating. And if you want to look at numbers, we can just kind of look at numbers. You can see when it is starting off, the initial velocity is 0, and that's something that's important to remember, that something that's dropped or just falls, the initial velocity is 0. It starts at a distance of 0 and a time of 0, so everything's zeroed out. And then after 1 second, it's moved almost 5 meters, and its velocity is 9.8 meters per second. Notice that 1 second, 9.8 meters per second. At 2 seconds, it's gone almost 20 meters, so it's gone much farther. And then the velocity is almost 20 meters per second, and it keeps going. And so the equations for this are down at the bottom of the page. You've got the final distance, how far it traveled, is equal to its initial distance plus the initial velocity times time. And in this case, for something dropped, all that zeroes out, which is nice and convenient. And so what's left is that 1/2 acceleration times time squared. And for an object falling, that acceleration is just the acceleration due to gravity, 9.8 meters per second squared. And if you want to just simply talk about velocity, the final velocity, the speed that it's going right before it hits the ground, is its initial velocity plus the acceleration times time. And once again, that acceleration is the 9.8 meters per second squared. So we talked a little bit about the acceleration. Now let's kind of turn our thoughts towards the forces. So we said force due to gravity causes the object to accelerate towards the ground. It's actually a force between, gravity is a force between two objects that pulls them together. So it's an attractive force, any two objects. So weirdly enough, picture anything in the room that you're sitting in right now, and you actually have a force due to gravity between it. It is really, really tiny, but the one we experience most is between us and Earth. Earth is massive, very, very large. You and the object in the room, not so large, so the force is tiny. We call it weight. So for physics, it's very specific. Weight is due to force. It's a force due to gravity acting on the object on Earth. How much matter is in an object we call mass. So those are two different things. You've got to keep those both straight. So let's talk a little bit about weight versus mass. Since I mentioned weight is due to the force on the mass, and mass is the amount of stuff in an object. We've got an example here where we've got this big dog, and he has a weight of 1,530 newtons, and we want to know what the mass of the dog is. So mass is in kilograms, and weight is a force, so it's in newtons. And you start off with F equals ma, which is force is mass times acceleration. And since force is a weight, it turns into weight is mass times the acceleration due to gravity. And if you plug things in and divide out so you're collecting all your terms, you end up with the dog has a mass of 156 kilograms. So he's a big old dog. And then let's talk a little bit about, the ideal world physics, which is cartoon physics, and then what really happens. So you're thinking, okay, so I drop a piece of paper. It doesn't speed up as it goes towards the ground. I drop a feather, I don't see that. You see lots and lots of videos of the skydivers, and they hit what we all call terminal velocity. So there's a spot where you don't get any faster in the real world. This is caused by air resistance. So there's actually friction due to the air when you move through it. And we don't feel it in our everyday lives, but the paper feels it when it falls, and feathers feel it when they fall. And if you are a skydiver, you will have experienced that air resistance. And so what we do is we assume that there's no air resistance or an object is falling in a vacuum. You may have seen videos of that. And this just makes things simpler for us. So this is in an ideal world, all objects fall to the ground with the same acceleration.